So again, thanks for joining. We are hosting a virtual user group, which a little bit of a change. We were planning on doing this as an in-person meeting, but these are unprecedented times, so here we are. So I just want to give a quick intro about Elite. This is the company that's sponsoring, and then go through the schedule, and we'll get started with the presentations. So Elite is a manufacturing company. We have a couple of factories. We produce parts mostly in aerospace, not exclusively, but primarily. And then we also have our engineering services division, and that's the group that I'm a part of. And we are a PTC partner, so we're a reseller of all the various software, as well as we provide different services, roughly outlined here. So today we'll be focusing on Creo, and we'll be looking specifically at an extension for flow analysis. And this was created by Simerics. So they'll be the ones giving the presentation today, showing us how it works and helping us to get going with it. So let's just quickly look at the schedule. Today is the Creo Flow Analysis workshop. Rich Moore will give us a quick intro. I'll pass it over to him in just a moment. A week from today, on May 6th, we'll have Walt Brewer from PACCAR giving a presentation on the benefits of workflow supported processes. So PACCAR is a company that's part of Kenworth that makes trucks. They are a pretty significant user of Windchill. They've got a lot of users, and it's pretty well developed. They have a lot of advanced processes, so they'll be sharing some of their lessons learned. And then the week after that, we're lucky enough to have Dave Martin, who will be giving a presentation on typology, generative design, and additive manufacturing. Dave is an expert when it comes to Creo, all things Creo. And actually recently he's also been a bit of an advocate for Onshape as well. So I'm sure he'll tell us a little bit about that, which was a recent acquisition by PTC. So without further ado, I'd like to pass it off to Rich Moore from Simerics, who's going to get us started with today's event on Creo Flow Analysis.
Thank you, Stuart, and welcome everyone in attendance today. And we really appreciate you taking an hour of your time to learn about Creo Flow Analysis in detail. My name is Rich Moore, and I'm joined today by Alex Chang, who is our lead application engineer for Creo Flow Analysis. And I'm going to very quickly take you through the digital fluids that you can create in Creo Flow Analysis for Creo designers and engineers and analysts that you might have within your company. Explain to you what it's based on, how it connects everybody from designer to analyst, what are the advantages, a couple new items in Creo Flow Analysis, and what are the Creo Flow Analysis best practices, and we'll jump right into the workshop. We are based in the Pacific Northwest, headquartered in Bellevue, Washington. And for the last 14 years, we have developed the leading analyst CFD platform called Simerics MP and MP Plus. And on that platform, we built PumpLinks, which is used by companies to simulate pumps, valves, and compressors. Orca 3D Marine CFD. We've taken the entire platform in purple, embedded that into Creo Parametric in the form of Creo Flow Analysis, so that you get usable, affordable, and reliable CFD as a parametric CAD user. Also an integration with CF Turbo if you do any turbine designs. Cases Simerics MP for the high-end optimization. GTI for 1D to 3D into Creo Flow and back to 1D for system simulation. We have integrated with Rhino, if you have any Rhino licenses, Rhino Flow RT and X, and as Stuart mentioned, the new addition from Onshape. So I'm going to just focus very much on Creo Flow Analysis, and with Creo Flow Analysis, you can also add clusters. So just so you know, Simerics was founded in 2006 by YJ who is considered the foremost formula and equation writer in the simulation marketplace, and Mihao and and they all met in Huntsville, Alabama at CFD Research Corporation, where they wrote custom code for NASA and Navy and DOE and DOD, and really learned what to do and what not to do when it comes to CFD. I joined Simerics in 2016. I was the first business person hired by SpaceClaim, acquired by ANSYS, and sort of those two milestones, plus our customers, partners, and employees have created Simerics Inc., where we've embedded our leading analyst platform into Creo Parametric. So digital fluids created in Creo Flow Analysis comes from Simerics NP. And we like to say to you that you can't fix what you can't see. You certainly can't change what you can't see. So we give you the ability to model fluids and heat and 1,500 other properties that you just can't see today unless you build the prototype, run, and operate the prototype. So we really want to help you with those modeling capabilities. Creo engineers meet analyst CFD functionality. No one else has embedded the high end of CFD into CAD in a usable, affordable, and reliable way, and connected to the analyst team. So you see here the purple platform and how we embedded this into Creo Parametric in the form of Creo Flow Analysis. And we have 3 base packages. At some point, Stuart and Ryan and team at Elite are intimate with these packages, so they can go through these in detail. But it's really meant to solve from a fluids and heat problem all the way up to multi-phase and multi-components, including cavitation. We have a very strong capability in anything that moves, slides, or rotate, and the Creo Flow Analysis Plus package in the middle there, as you can see. One of the advantages that we bring is what you see in purple is what analysts are using out there today from Simerics, and the file extension is .Simerics project SPRO. Anything that you create in Creo Flow Analysis, you can save as a .SPRO file and give that to an analyst. And if the analysis group has a Creo Parametric license, anything that they create in Simerics NP Plus, they can give over to the Creo Parametric team. So it's a really nice round-trip, two-way integration between analysts, engineers, and designers. We have some real advantages that you'll see in the workshop today. First and foremost is our automatic and efficient mesher. This is a very complicated underhood automotive conjugate heat transfer problem. And what we do is we automatically mesh this, starting with the coarse mesh. We go fine, finer, and finest automatically around every sharp edge and every complex piece of geometry that you have. We body fit that. So think of fit, and then we split the mesh in half and connect those to YJ's formulas and equations here, so that we iterate 50% fewer times than any other solver in the marketplace. So think of an automatic and efficient mesher even when things move and slide, and then think about 50% fewer iterations. We also fit into the PTC digital thread, where we paint and animate in real time. You can output that to Vuforia Studio, as you see here in this example. We also have a integration with Creo Simulate. So you see Creo Flow Analysis on the right-hand side. We can take the pressure temperature and pass that to Creo Simulate, so you can use that to calculate your deformation. Of course, we're fully associative with Creo Parametric, change the geometry, and all the simulation settings stay in place. The software just automatically remeshes the geometry for you, integrated with Vuforia, integrated with Windchill out of the box. And this is an example of the Creo Simulate integration, where we take the pressure temperatures from above and pass that to Creo Simulate below. This is the Vuforia Studio integration, where this aircraft is flying at 300 miles per hour with a 3-degree angle, where we output the animated streamlines to Vuforia Studio. This is the whole digital thread of PTC, Creo Parametric, Creo Flow Analysis, Vuforia Studio, and Windchill to select, do I need a large windshield or medium or small based on my body type, as you can see here in the picture. One of the advantages that we have is we use the same development kit as the PTC developers that develop Creo Parametric and Creo Simulate. We are the strategic partner for CFD for PTC. We're integrated in Creo 4, 5, 6, and now 7. In a year, we'll be in 8, and then 9 and 10, and so on. And what you get is Analyst CFD functionality embedded into Creo Parametric and body fitted so that you get great results. PTC and their resellers have had tremendous success selling Creo Flow Analysis to hundreds of companies. As I sort of flash through these, you can see in just 2 years, they've sold over 400 companies now, over 1,200 users. It's just the adoption has been phenomenal, quite frankly, and it's been a great partnership. We do the development for the most part. We get a lot of help from PTC, especially on the testing and QA. They do a great job, but we also do the support and we also do the training. And we offer online training if you need it, and also on-site training. So with that, let me turn it over to Alex, who will walk us through the workshop. Go ahead, Alex.
Okay, thanks, Rich. Yeah, so again, my name is Alex Shea. I'm the lead application engineer for Creo Flow Analysis here at Simerics. And now I'd just like to walk you through, to start, just kind of the features available to you in Creo Flow Analysis. Oh, one moment here, sorry. Okay, so as Rich has mentioned, Creo Flow Analysis is a full Analyst CFD package available in Creo Parametric. So what CFD is, just for those that aren't sure, we use numerical analysis and data structures to solve fluid flows. And so how that works is you can start with your model. And from there, we'll mesh the model. So what we do is we break it down into smaller elements. In this case, you can see little cubes, little arbitrary shapes. What we'll do is from there, you can input your working conditions. So you give us what you know at the beginning and the end, and we'll solve everything else in the middle for you. From there, you can get results. So the advantage of CFD is, it gives you very high fidelity results that are very difficult to perform with hand calculations, right? With numerical models, you get a new level of depth and understanding of the fluid flows in your designs. And so, yeah, Creo Flow Analysis. Again, this is analyst level CFD. You have all the same controls and physics that are available to analyst divisions all over the world. And for us, the technologies that we have that make it usable for a wide user base is the fully on mesher. We have tools that we've developed thanks to our integration with CAD packages, right? Like the automatic fluid domain extraction, which is a huge time saver. We have a built-in fluids database you can get up and running immediately. We take your material assignments from the assembly and import them automatically. So there's a lot of kind of quality of life features in the software that just make it very practical and usable in a design workflow. So now we'll step through the features available in Creo Flow Analysis. And this first one, I'd say is one of the biggest ones for usability, is the wizard workflow. So for first-time users, and just if you only use the software, maybe every other week or so, you don't have time to internalize the steps. What we do is we break down all the steps and properties that are needed to set up a CFD analysis and lay them out in a nice, straightforward UI. So you basically turn it into form filling. So it's great for, just that guided workflow. As I mentioned, we have that automatic fluid domain extraction. This one's really nice, actually, because the traditional workflow is, you have to go through, click all the surfaces, merge them together, and then try to solidify them. But in our case, we've boiled it down to just a few clicks, and we'll see that in the demo in just a moment. Okay. And then we have our fully automatic mesher. So you can kind of see how it works here in this top right image. We use a arbitrary hex mesh or Cartesian mesh, and so how it works is our base cells are these cubes, right? So as we approach the boundaries of the geometry, just the more complex areas, sharp edges, curvy sections, the cells are able to start subdividing themselves. So first into smaller cubes, so 1 into 8 into 64. And then from there, the cubes are able to split themselves into any shape needed to actually match the geometry. So we have a fully body fit mesh that represents your model one-to-one. So there's no approximations. There's no special meshing required to resolve any approximations in the mesh. The mesh is one-to-one body fit to your geometry. So the fluids materials database, we have a kind of just most commonly used list of fluids available to you from the get-go. You can also add in your own custom fluids if there are any that you use often that aren't listed here. So we can do constant density fluids, we can do compressible gases, so ideal and isentropic gas law. We can do compressible liquids, pressure-dependent fluids, pressure and temperature-dependent fluids, equations of state, non-Newtonian fluids, and we cover the entire spectrum here as far as fluids and what you can simulate. Okay, and then this kind of marriage of CAD and CFD brings with it a host of advantages. One of the most exciting for me is this project update. So at any time, with flow analysis, you can always go back to the model. You can open up parts and modify them. You can reconstrain components in the assembly. And then you just click back to the flow analysis ribbon, hit update project, and then we'll update the project according to those geometry changes. So in this case, we take our smoothbore nozzle here, we reduce it from a 9/16 bore to a 1/2 inch bore. And with just 2 clicks, right, we can see the results on the updated geometry. Okay. So as far as outputs go, we can do those kind of surface contours that you've been seeing with pressure, temperature, velocity, density, gas mass fraction, just whatever you might be looking for in your fluid analysis. We can output integrated values like mass flows, pressure drops, flow rates, right? Great for, say, manifold balancing, right? Other applications like that. And then we can also create animations that you can use in your presentations or for your own reference and understanding of what's going on inside the model. And then we are integrated with Creo Simulate. So what we can do is we can take the pressure distribution or temperature distribution that's solved in Creo Flow Analysis, right? So it takes full consideration of a dynamic fluid into consideration. So, like wall friction, velocity, density changes. You get the full picture of the fluid contribution to your design. And then we can take those, so pressure or temperature, and then export them as a load in Creo Simulate. So again, pressure or temperature as a external coefficients field. So again, this fills in that missing piece in some of your FEA analysis, perhaps. You can get the correct deformation, either thermal or pressure based, due to the fluid running through your models. All right, so now I want to take you through the each physics module available in Creo Flow Analysis, and also offer some examples, see if they fit your use cases. And so we're starting with the base package here. And with the base package, you get flow. So flow covers internal flows, external flows, or both. You can see some examples here. We have the boat here, porpoising through the water. That's an example of a both analysis. We have some examples of external flow analyses here. So here's one we did. It's a hockey helmet, right? They wanted to look at the thermal comfort of their design as well as the aerodynamics of their design. And then an example of an internal flow here is a turbocharger. Right. And in addition to the flow, we also include heat. So heat specifically being conduction and convection. So fluid to solid, solid to solid is included. And so the most common use cases I've seen for the base package are, electronics cooling, right? Modeling different electronic components and their temperature distributions, thermal performances. We've seen a lot of manifold balancing, or just, like turbo or exhaust pipe analyses. A lot of heat exchangers, and then you can see down here, one of the more advanced cases that is still coverable by the base package is this underhood flow analysis. So you can see there are thousands of components, all of them fully modeled in the underhood of a car. All right. And then now we're on to the Plus package. So the Plus package adds a lot of great kind of bells and whistles. So we do have the particle analysis. So this is a great way to see how well particles will distribute throughout your design. It's also a post-processing tool, right? You can inject particles of varying density and see exactly where they would go in the model and just kind of better understand the flow again. And then we have also recently added particle erosion modeling. So if you have, say, sand in your flows, be it in fans or oil, we can actually model the expected impact of erosion, so the thickness and the damage power on your wall boundaries, so you can have a much better idea of the life cycle of your designs. So I've seen particles, their biggest application has been in the oil and gas, especially working with crude oil. We've done several cases in that area. And then the Plus package also brings radiation, so that third component of heat transfer. Right. So for radiation, you can add solar loads to your models, or see how your design will perform out in the open with direct sunlight on it. You can control the direction. You can set it as a function of time. And for our radiation module, we use surface to surface. We use ray tracing for the surface to surface calculations. So how that works is for each cell in the model, we emit the default value is 256 rays. And from there, we can determine, what surfaces see what. We can calculate the reflection and diffraction of where the heat is going. So you can see some great examples here on the right. So this little office building here, we have a solar load somewhere around here, just a distributed load. You can see how it's able to trace out the reflections on the awning. You can see how it's able to pass through the glass, right? And trace these arbitrary shapes here. So here's an example, right? A keyhole and a parallelogram. You can see how they're traced out accurately on the ground. And that's again thanks to our use of a view factor, ray tracing calculation. Radiation gives very accurate and detailed results as far as radiation goes. Species is one of our more niche applications, but there's still use for it. We found that, so what this allows you to do is basically solve another transport equation, so track an ejection of another fluid of a very similar density. So in this case, we're looking at a microfluidics example. So it's basically water injected into water, but they still stay as two separate entities just because of how fine detailed the flow paths are. In this, it's on the order of nanometers, so it's able to maintain that without too much diffusion. Also, chemical species transport is a common use case for species. And then kind of the star of the show, I'd say for our plus package is the moving and sliding mesh. So thanks to our special meshing technology, because the cells are able to cut themselves into any shape needed, our mesh can freely rotate or translate depending on how you define it. So of course we'll see a lot of fan analyses here, pump analyses. And for moving and sliding mesh, we win hands down in every category, on speed, on robustness, on accuracy. This was kind of the company's specialty coming into the market, and it has remained one of the company's strongest points. All right. And now we're on to premium. So this is where we get the really advanced physics. So we have cavitation, right? So for propeller design and centrifugal pump design, this is a very important consideration because, as the blades rotate through the water, they'll start to create bubbles due to the sharp pressure changes. And then those bubbles will form and pop and start causing damage on the rotor or propeller. So you see here in this top right example, just the cavitation risk zones, where you're going to start seeing pitting and the like. So I know a lot of customers, especially with pump design, they just run their model on the test bench for a couple hours until it breaks, take it apart, and then look around for cavitation pitting. But don't understand, what exactly is happening, what's really causing it, and where it's actually forming. So using CFD, you can actually really understand what's going on in your designs and make design changes. More educated design changes. All right, and then we have multi-phase, and this seems to be the largest driver for premium packages. So you can model two completely different fluids. So in this case, you can see oil and water, and then, oil and air, and then water and air. So a lot of fuel tank filling and draining, ice, like toilet flushing, faucet analyses, spray analyses, coolant filling and draining, times. It's very powerful, very fast, and very accurate. And then we have multi-components. So if you're interested in modeling, say, for example, air as its constituent components, so instead of as a single fluid, you want to see, carbon, nitrogen, oxygen, where they disperse to, kind of how the distributions work, then that's where multi-component will come into play. All right, and then last, but certainly not least, is our dynamics module. So this is most often used for valves. You can add your spring constants, initial loading forces to your valve designs. And then we can solve for the displacement and effects on the flow in real time, right? As you can see examples here of our dynamic valves, and we can do full 3 degrees of freedom. And all right, so let me go ahead and switch over to Creo here, and we can jump into a demo and just kind of see everything I was just talking about in action. So what I would like to look at, since we're a bit tight on time, is we have this power inverter here, which gives a great example of electronics cooling, or what we use, the term we use is conjugate heat transfer. Just really look at the advantages of having CFD in your Creo workflow. And so for this case, we are just using the base package, so flow and heat. You can see right off the bat, all right, instead of having to open a separate tool or anything, all you need to do is click on Applications, Flow Analysis, and all we do is switch out the ribbon, right? Actually, one moment. Let me fix my screen here real quick. I hope that looks a little better. I know there's a little clipping on the other monitor. But yeah, so no need to, relearn how to pan or rotate, right? All the controls, base controls are the same. Same environment, same environmental variables and configurations. So nice seamless jump into the CFD. So what I want to demonstrate here is kind of the wizard workflow. We take our little power inverter here, all its components model, right? Ready for its first validation. Run it through the wizard and then get results. Okay, and so we'll just see how the wizard works in action. So, you can name your project, give it a brief description for your reference, refer colleagues if you decide to pass the project over to them. This is integrated with Windchill, which we forgot to mention. So you can take your analyses with your models into Windchill, have those stored there. So we're just going to go through the steps as the wizard kind of asks. So the first step is to choose our physics. So we're going to grab flow turbulence, heat, and streamline. You're currently looking at the full list of physics modules in Creo Flow. But right now I'm using all of the physics available in the base package. Again, it'll ask us questions, right? In this case, gravity force isn't really going to do anything, so we'll leave it as no. Do we want to create fluid domains? Yes, and so this is where we can also kind of select the type of analysis we want to run. So internal, external, or both. In this case, we just want to run an internal analysis. So go ahead and click on there. And so it'll begin initializing the fluid domain extraction tool. So we have on the screen our full assembly. From here, all we need to do is click openings, faces, and then select any surfaces in our model that contain openings. So inlets, outlets, vents, or the like. In this case, we just have the inlet and the outlet at the fan area. We can take a quick look at the preview of the fluid domain that's detected. We'll click OK. And you'll see the fluid domain appear here in the model tree and in the workspace, right? And then if we open it up, you can see that it is its own part in the assembly. It is fully associative with your model. Take a look here, and it does in fact contain all of the internal detail there. Right. So what traditionally was at least an hour, 2-hour slog through clicking surfaces is now been reduced to a few mouse clicks. All right, so back to the wizard. We're just gonna click next and do what the wizard asks. And in this case, we're now going to add our domains. So one thing we elected to do with Creo Flow Analysis is instead of just grabbing, assuming that everything in the assembly is what you want to simulate, we allow you to pick and choose exactly what parts you want to analyze. So no need to go through and suppress parts or create simplified reps. You can just pick and choose here in the software itself, and just kind of maintain the consistency of your models, especially if you have them checked into Windchill. And so by default we have air, which is what we'll be using. You can see kind of a list of the fluids we have, and we can also control the density, although in this case constant density will more than do the trick. And if you want to add your own custom fluids, you can just go to the materials in the ribbon, custom materials, and then just input it here. All right, and now we'll add our solid domains. So this is kind of where the no need to suppress thing is very handy. I'll be using all of the parts in the assembly, but again, you can always pick and choose. And so our assembly here already had materials defined. So if you were using a non-integrated package, you'd have to export a spreadsheet, right, of material assignments and reapply them. In this case, we can pull directly from Creo. And so we can pull from the local database on your machines. We can pull from Windchill databases as well and import them automatically. You can also change them on the fly. If that's of interest to you. All right, now we're on some boundary conditions, right? So this is kind of the beginning and the end that you input. So this is based on the working conditions, either to match your test bench setup or to look at the kind of expected working conditions that your design will exist in. So we'll start with the inlet here. The inlet is just kind of a vent cover. So for this, we can just set it as a pressure inlet, so that it's a 1 atmosphere of pressure. So it's just an opening out to atmosphere. Here we can also release our streamlines. So if you notice those kind of animated lines moving through a lot of the GIFs we've shown you today, that's what those are. So we'll just toggle them on. And so they'll just trace from the inlet all the way to the outlet, so we can get a good understanding of how the flow looks animated in 3D. The nice thing about the wizard is there is a lot of automation under the hood. Again, this is a full Analyst CFD package, so there are all kinds of controls and parameters that are available to you. But for the most part, you just want to get your analysis set up, done, look at your results, and then start making design changes or comparisons. So we've automated a lot of those to just be the optimal setup for most use cases. So another thing is, because we chose heat, we also get our heat parameters that pop up. These would not show up if we didn't have heat, and we don't want to add in extra steps. Again, we're just here to streamline your workflow from design to simulation back to design. All right, for our outlet, we just want to study a static flow rate. Right. If we kind of just set our fan speed to a certain speed, how the performance will look is that set that as a volumetric flow rate. And we will let it solve as an outlet. So we tell it, the incoming temperature is room temperature. And then just based on the conditions as it flows through the power inverter, just solve the temperature itself at the outlet. That's it for boundary conditions. Now we're on to volume parameters. And so this is where we can apply heat sources in this case. So for example, we have our chip, our thermal chip here. We want to set that as a heat source of 5 watts, right? And we can go back in, set additional heat sources. In this case, our transistors are definitely generating heat. I'll just grab them. You can set multiple volumes at the same time. Again, as a heat source, total heat source, and say 2 watts here. So now we have a total of 5 heat sources in the model. You can add as many as you want, really. Our kind of solid thermal solver is built right into the fluid solver. They're kind of integrated from day one as a singular code. So it's very fast and efficient for these conjugate heat transfer analyses. We support steady and transient problems. And steady state solves to a steady state, so kind of the equilibrium point you'd expect, how your model would operate 90% of the time. If you're interested in heating and cooling times, we also do transient analyses, and that is a one-click switch. No need to create a new project for that. So with this, we can run the analysis in terms of real physical time. So you can see, how long it takes your components to heat up or cool down. All right, and then now we're on to mesh generation. So again, fully automatic mesher. Really, the only inputs you may ever need are this maximum, minimum, and cell size and surfaces. You can reduce these values if you want higher fidelity results. I found in my year and some change working with this software that the default parameters work very well and fit experimental data extremely well, especially integrated values like pressure drop or flow rates. We're always within 1 to 5% on the first pass. And again, that is with the default mesh parameters. And so as you can see, in addition to being very easy to use, it's also very fast and robust. You benchmark this against any other software, we win hands down on meshing. So now we're on the last step of the wizard, which is really just kind of outputs we want, right? We want some hard numbers on our design to gauge its performance. So in this case, I'll grab, say, our heat sources, right? Maybe we want to take a look at the max temperature that each of them are looking at. We just switch them on, and then we can throw them on separate XY plots on the same one for direct comparison. It's really up to you. You have a lot of control here, how you want your data presented. In this case, I'll put the thermal chip on its own plot, and then the transistors on their own on another plot. And from there, we're ready to go. So I'll click next. And then one more. So at the outlet, maybe we can put out the temperature, right? See how much more of the fluid itself has heated up after running through the power inverter. We can also output the pressure, maybe look at the pressure drop across the bottle, and just add these to their own XY plots, right? Nice and easy. Finish, and then run. So now you'll see another one of our really cool advantages here that we haven't mentioned up until now, is that we can render our results in real time. So instead of having to wait however long for your simulation to finish, you can immediately see the results from the get-go. So what I'm going to do is I'm going to color all of these internal surfaces with temperature. Go ahead and hit refresh on the range. Already, right, we can see our results just as it solves. And so it'll constantly update if needed, but find that in the first tens of iterations, it already has a good idea of where it's going. Maybe I can run it again just so we can see how that looks. Right, starts with our initial conditions, and then it can immediately start solving and rendering those results. Again, Creo Flow Analysis is a full CFD suite, all integrated into one workspace. And then now I'd like to take you through some of the post-processing. Of course, we have our contours, which we're looking at right now. Any one of your parts, color all the surfaces with variable pressure, temperature. That's the, whatever you might be looking at, and render those. And of course, we have our section view, right? 2D plane, XYZ, arbitrary. Color it with pressure, temperature again. You just kind of walk it through the model. Get that high fidelity view in 2D of the fluid and solids. We can also clip off the simulation surfaces and just, I found it makes for really good results for presentations and the like. And get very creative with how you want to present your results. And I'll just kind of go down the list here. We have our isosurface. This is really cool, especially for electronics cooling. What we can do is select a variable, say in this case, temperature. We can set the criteria to above value. And now we can see where our temperatures are highest throughout the model, so fluids and solids. So this is a great way to kind of see where your hotspots are, where the heat kind of collects and recirculates in your model, where it might be getting trapped, right? And then we have definitely my favorite is our streamlines. Go ahead and add a few more here. Go ahead and take a look. So you have choices here. We can first do this kind of rope view, right? Maybe we can color this with velocity magnitude. You can trace the flow, right, from the inlet to the outlet and then see the values along those lines. And we can also animate them. So they are animated relative to their actually solved speeds, right? So this is just another great way to get a better understanding of the flow in your design. You can visually see where your turbulent areas are, where you might have recirculation and the like. And we can take a look at our XY plot panel here. So these are the plots that we created in the wizard. So we have the max temperature of our thermal chip here. We have comparative temperatures of our transistors here. We have the pressure value at the outlet, so we can calculate the pressure drop. We also have the temperature. We can see that the fluid has heated up about 11 degrees, just running through the model on average. And so with this data, you can copy it to your clipboard, or we can save you a step and export it to a CSV file. It's kind of your preference there on how you like to manipulate your data. And then, yeah, so maybe one more thing is we can take a look at how the temperature export works. So for any surface contacting the fluid in the model, if we go down to output, you see we have this, we do heat coefficient distributions if you want to export to another CFD package or a FEA package, sorry, that you're using. So have the temperature distribution here. You can see one of our outputs is literally Creo Simulate. So this creates that FNF file that you can use as a temperature load in your FEA analyses, right, for thermal stresses or deformation based on the fluid's contribution. And kind of one last thing I want to show you here in the model tree. At any time, we can go back to the model itself and make changes. For example, maybe what we want to do is take this big capacitor here, maybe move it over a little more to the left here. Just kind of let me show it. You can see. Move it over, maybe open up this channel a little more because we see a lot of heat collecting there. Shift it over a few millimeters, maybe down a few millimeters. Click OK. Come back to the project ribbon, hit Update Project. And what it'll do is, it'll just recreate that fluid domain. It'll remesh the model, reapply all the settings before, so the boundary conditions and volume conditions that you set. So this allows you to, just make those back-to-back runs with different considerations for different kind of layouts of your designs. And you'll see in just a moment, we also preserve all of the post-processing. So as soon as you run this updated geometry, you also have that direct comparison from before. So we maintain that temperature range so you can visually see the difference immediately. Let me hide this guy. All those streamlines still there, the section views, the isosurfaces we created. Just like that, right? You can make design changes, great for design exploration or just kind of fine-tuning your designs. I think that's all I had for you guys today. Thank you again for coming out and your time today. I think I'll turn it back over to Rich at this point for some closing comments, perhaps take some questions.
Thank you, Alex, for the deep dive into the different physics and meshing capabilities, painting and animation in Creo Flow Analysis. Let's open it up to the group. Feel free to take yourself off of mute and ask a question, or if you prefer, you can use the chat box and either send that to me or Alex, or actually to everyone. But let's just see if you have any questions that we can address. You can see that it's part of the PTC digital thread integrated with Creo Parametric and Vuforia Studio and Windchill and Creo Simulate. It gives you the Analyst CFD functionality in a very usable, interactive way using the wizard, where you basically take your Creo Parametric design and put that into the wizard, basically turn the wizard on and answer about 15, 20 questions based on your assembly, and out comes the results. So it's really high-powered CFD in a very usable and affordable way. So let me just see if any questions. Doesn't look like we have any questions. Let me just turn it over to Stuart, who will describe the follow-up from this virtual user group meeting today. And again, thank all of you so much for attending and participating. Thank you.
Yeah, thank you very much, guys. So if there are any other questions, or anyone wants to see any follow-up about fluid analysis, feel free to reach out to, this is Stuart, you can reach out to myself or to any of the elite personnel, as well as Simerics. Reach out to Rich Moore as well. So at the very least, you all have my email address. You can contact me. I'll get you more information. And if anyone wanted to see some other use cases or talk with some other users, I could certainly put you in touch. That's kind of the idea with the user group, is giving chance to speak to other users. So we do have some customers that use CFD and would be happy to share. And lastly, next week will be the presentation by PACCAR on how they're using Windchill. So that'll be an interesting one. Invite everyone to join again. And please let us know if there's anything else that you'd like to see. Rich and Alex, thank you very much for the demo. As always, it's really cool to see what you can do with the fluid analysis. So appreciate the live demo in the workshop. I think that was a great resource for everyone.
Well, thank you, Stuart and Elite Aerospace, for supporting the PTC user group and the Creo Flow Analysis application. Thank you.
Thanks, everyone. Well, stay safe and have a nice day.